Okay, so let us have another example here on joint probability. So in this problem, Michael is an avid sports fan who likes to assess runners' chances of having podium finishes. So for those of you who do not know what a podium finish is, that is basically getting into the top three. So this is actually the podium. So in this course here, or in this problem here, so once again, Michael is an avid sports fan who like to assess runners' chances of having podium finishes. Okay, so in the upcoming men's 100-meter tournament, Michael assessed that the chances of the two athletes named Eric and Brian reaching the podium finish will be the following. So Eric, according to Michael, Eric has a 60% chance of reaching the podium finish. So Brian has an 80% chance of reaching the podium finish. And with that, guys, or aside from that, Michael also assessed that the chances of both Eric and Brian reaching the top 3 is 40%. If you are confused here, this 40% represents that both Eric and Brian will be included in the podium. So in the 60% chance here, this indicates that Eric has a 60% chance of going to the podium regardless if Brian is there or not. So 80% here represents that is the chance of Brian getting in the podium regardless if Eric is also there. And for this 40% chance here, both of them must be in the podium. Okay, so determine the probability that at least one of the two athletes, Brian and Eric, will reach the top three. So let us say that B is for Brian, and let's say E is for Eric. Okay, so in this problem, we would now be determining the probability that at least one of the two athletes, Brian and Eric, will reach the top three. Meaning, guys, our total event should be the union between Eric and Brian. So once again, at least one of the two athletes. Okay, so if you are thinking, why shouldn't it be the case that our equation should be E in intersection with B? So why is it the case that this should be our equation and not this? Because this equation here represents that both Eric and Brian should be at the podium finish. But for this equation here, this represents that either Eric or Brian should be in the podium finish. Okay, so you can review our Venn diagrams here. So again, let's suppose that this is E and this is B, or Eric or Brian. So if, for example, that Eric makes it to the podium, it means that it covers this one here. If Brian makes it to the podium finish without Eric, it means that it covers this area here. But if Eric and Brian reaches the podium finish, it means that it now covers this area here. And once again, in our problem, we are now to determine that at least one of them will reach top 3. So meaning, guys, that we will cover the whole area here. Okay, so with that being said, guys, our equation, or the equation that we have derived earlier, so the probability of Eric in unity with Brian is equal to, so we would just be adding the probability of Eric reaching the podium plus the probability of Brian reaching the podium minus the probability of both of them reaching the podium. Okay, so once again, why do we subtract this value here? So this value here, or the subtraction of the probability of their intersection, is for us to prevent redundancy. Because once again, when we have solved for the probability of E, in our data, we have used all of this. Okay? And for the probability of B, for that data, we have solved for the whole of this. And since we have used this area here twice, or we have computed for that area twice, we will now be removing a part of it, or we will now be removing it to avoid redundancy. So if you want to learn more about that, please watch the previous video lecture once again on the introduction of joint probability. Okay, so this now equal to, so what is now the probability of Eric reaching the podium finish? So that is 60% or 0.6. Then what is now the probability of Brian reaching the top 3? So that is now 80% or 0.8. Okay, so what about for Brian? So Brian, or Eric and Brian in the top 3 is 40%. So meaning that we would now be subtracting 0.4 here. So from that, 0.6 plus 0.8 minus 0.4. So 0.6 plus 0.8 minus 0.4, that is now equal to 1.0. So 1.0 in terms of percentage, that is equal to 100%. So if you would be multiplying 100% by 1.0, that is now equal to 100%, meaning that according to the study of Michael, it is a certain, or it is for sure, that at least one of the two athletes will reach the top 3. Okay, so that is the implication of this data.